Thank you, Mishi, for that informative presentation. We'll now be moving on to the question and answer portion of today's webinar. And just before we start, there's several questions about cleaning that people asked, and Mishi discussed the cleaning procedure. So if you have additional questions about cleaning, if you'll go ahead and ask those questions specifically. Otherwise, I won't go into the questions on cleaning that have been asked. So Mishi, the first question that we have is, at what speed is it best to implant the probes to prevent bending of the shanks or dimpling of the dura and tissue?
So when you penetrate the brain, there is not really like a speed. The best practice is just going down, up and down until all the shanks can penetrate. But once you penetrate it into the brain, then this recent paper showed that like this 2 micrometer per second speed is the best to obtain a good quality acute recordings, but as slow as possible. And like as a rule of thumb, we generally reach hippocampus in 30 to 60 minutes in an acute recordings, which is 1.2 millimeter in a mouse and 2.2 millimeter in a rat.
Okay, the next question is, can chronic optoelectrodes be longer than 5 millimeters, or was 5 millimeters just an example?
So as of now, it's only 5 millimeters, but Professor Yoon asked everyone to send them directly their wishes, because they are going to change the current design and they might be able to incorporate longer shanks. But as of now, only the 5 millimeter shanks are available.
Okay. What kind of printer and material do we need to use the drive?
So we use the Formlabs Form 2 printer, and with the most typical resin, which comes in many different colors. But all these informations are available at the Yoon's group GitHub page. And we can also send you directly the CAD files, because the tolerance is changing from printer to printer. And these drives are specifically made with a 100 micrometer tolerance for this specific printer. But if you have access to another printer, you might need to change this tolerance to 200 micrometer. And then we are happy to send you the CAD files, and then you can do the necessary modifications.
Okay. And would this setup also be possible for awake recordings?
Yes, so the microdrive option that I showed, and I showed in this day 1 and day 16 recordings. So once you build up this Faraday cage, you can protect the probe, and then the animal can move around, and then you can lower your probe day by day and then collect the data as long as you have good quality neuronal signal.
And are the micro LED probes stronger than other silicone probes? Are they easy to handle?
It's the same.
Okay. The same as the silicone probes?
Yes.
Okay. And then one person has asked, what is the length of the implantation procedure? I think they might be referring to the amount of time.
So that really depends on surgical skills, but I would, and also the location, like whether you implant the probe in an angle or not, or to some peripheral brain regions. But I would say something between 3 to 6 hours, depending on the complexity of the surgery.
Okay. Have these been used in rats as well as mice?
Yes.
And do you have an estimate of how many times you can reuse the probes?
So as I mentioned in my presentation, that acute probe, we reused already 7 times, and it's still sitting in our surgery room in Michigan. So if you are careful with the insertion and then you pay attention to the cleaning, then I think an acute probe can be reused multiple times. Like how many I really cannot tell, but at least 4 or 5 times for sure. In a chronic animal, it has its own complications, like the probe can just break during the recordings, or there could be some bleeding in the craniotomy, and the dry blood can break the probe. But normally you could reuse them, I would say, at least 2 times.
Okay, and then.
But sorry, just one more thing. But all of these are really meant to be a single-use devices. So, but it's possible to reuse them.
Okay, understood. Can you talk about how and where you tie the micro LED ground to the recording ground in current versus voltage mode, if you ever tie them together at all?
So there is a tiny, or actually 2 tiny pads already on the PCB, on the backside of the micro LED probe PCB, where you can just put a 0 ohm resistor or just tie them together. Or once you, and I think that's one of the best options, because then you don't really create any big ground loops. But another option just can be like what I am personally doing is the stimulation unit is sitting next to the recording unit, and then I'm just grounding the 2 together there.
Okay, and what biocompatible silicone do you recommend for sealing the craniotomy?
So it's called the Dow Corning company specific silicone, but all this information is also available, like an Excel file is available with all the chemicals that we use during a surgery on the Yoon's group GitHub page. So you can just look it up, because the silicone is like only this one particular silicone is good that won't break the micro LED probes. But instead of silicone, you can also just use a wax mineral oil mixture that we used to use in the past for many, many years.
Are there examples of acute recordings in an awake animal?
Yeah, like acute recordings in an awake animal?
Yes.
I mean, if it's an awake animal, then I would say it's a chronic recordings. Like, I don't fully understand the question, but you could do that. Like you could do an experiment in which you implant the probe, you wake up the animal, you record one day, and then you remove the probe. But it's once you have an animal that is in a good condition, I highly recommend to keep recording for multiple days. And on top of that, after you let the animal wake up from surgery, generally you need to give a couple of days to let the animal recover and then start collecting data. So I don't fully understand this question.
Okay, the person who submitted that question submitted anonymously. So if you want to resubmit a question with more specific information, we can come back to that later on. Another person asked, have you tried recording without the copper mesh Faraday cage?
So in acute recordings, it's possible to get good quality signal without this copper mesh Faraday cage. But you need to have like a good like a recording room where there are no other EMI noise sources. And in a chronic animals, you need to, so the copper mesh acts as a Faraday cage, but it also acts just as a mechanical protection. And then you could replace this with some other ways, but now you have this copper mesh cage, which has 2 purposes. One is the electrical shielding and the other is the mechanical protection.
Okay, and what was the UV curable dental cement you used during the surgery?
It will be available on this GitHub page, but it's called the Unifast LC, and LC stands for Light Cure.
Okay, and we've received a couple of comments on the acute recordings question. and a couple of comments from some speakers that will be speaking in the webinar in the future. So a couple of those have said that they've done the recordings acutely in awake head-fixed animals. Lisette will be speaking next week, so she can provide some details on that. And then also another attendee just said, I think they are asking if anyone has performed acute recordings in head-fixed mice, like what has been done with the NeuroPixel probes.
Oh yeah, so that's true. I completely forgot. So yeah, that's a good point. Thank you, Lisa, for yeah. So first you can implant a head post, prepare the craniotomy and your ground wire, and then for each day you can penetrate to a new spot using either for that purpose the best is an acute probe, and then you could record during those head fix preparations.
Okay, and then we have, so someone's asking some more questions about the Faraday, the copper mesh. They want to know how the copper mesh acts as a Faraday cage, given it is open at the top and bottom.
So because it's grounded to the system ground, and yes, it's not a perfect Faraday cage, that's true, but it's better than nothing. And on top of that, especially for rats, we then cover the whole preamplifier with another piece of copper mesh, so the top is also completely covered. So it's basically not covered only at the skull surface.
Okay, thank you, Mishi, again for the presentation. And just for all the attendees, we will, this is recorded, and so we'll post this on our website, as well as we'll work to get better quality videos for the first parts of the webinar so that you can see those more clearly. Also, don't forget to register for next week's webinar. So a lot of the questions about the acute awake head fixed recordings. Hopefully we'll hear more about that next week in the talk functional microdissection of a hippocampal circuit with high density optoelectrodes. Thank you guys for joining us.